Hi everyone, this is Mrs. J, and today we're going to be solving quadratic equations using two methods, completing the square and the quadratic formula. But first, please pause the video and give this warm-up a try. All right, go ahead and check your work here. For part A, you can factor this. This is actually a difference of two squares, or you could use the square root method. You get the same answer either way. For part B, I would set it equal to 0 and factor, and it's even easier if you divide both sides by 2 to reduce down your numbers. And then for part C, I would use that square root method. So here, remember, it's okay to have the square root of a negative. We just put that I out front to have that imaginary unit. So we have plus or minus 3i root 6. All right, so the first new method we're going to talk about is called completing the square. But before we do the whole method all the way through, I kind of want you to see what the end goal of this method is. So if you look at this equation, so let's say I decide to factor what's on the left. I understand my equation is not set equal to 0, and that's a little strange. But here, if I factor this expression on the left, I actually get x minus 8 times x minus 8, which is x minus 8 squared. So if you're able to create a scenario like this, we could actually clear the square by taking the plus or minus square root of both sides. So we get x minus 8 equals the plus or minus square root of 10. And then I can actually finish solving for x just by adding 8 to both sides. So x equals 8 plus or minus root 10. And that would be our answer. So when we're completing the square, our goal is to create this scenario where we have something that we can factor into a binomial squared, which then allows us to get rid of the squared by taking the plus or minus square root of both sides. So that's going to be kind of our general goal when we are using this method. So you'll notice that what was on the left was a trinomial that could be factored into a binomial squared. An expression like that is called a perfect square trinomial. And again, it's a trinomial that you can factor into a squared binomial. So these are all examples of perfect square trinomials. So I want you to take a second and see if you can look at the relationship between our b values and our c values. So I'll do the c values in blue. And make sure you're accounting for the signs of those as well. So here our b value is positive 4. Here our c value is positive 4. Here our b value is negative 6. Here our c value is positive 9. Here we have positive 10, positive 25, and negative 8, 16. And again, I'm just looking at those coefficients. So one thing you might notice is that all of the c values are positive. And then hopefully you're kind of looking for a relationship between those two numbers. Well, these, if you notice, the c's are all perfect squares. This is 2 squared, this is 3 squared, this is 5 squared, and this is 4 squared. And all of those numbers are actually half of your b value. So we could say that our c value is actually going to be our b value cut in half and then squared. Right? If you take this 4, divide it by 2, and square it, you get positive 4. If you take negative 6, divide it by 2, and square it, you get positive 9. 10 divided by 2 squared is 25. Negative 8 divided by 2 squared is 16. Now, another thing I want you guys to notice is the relationship between these numbers and the number in your factor. So notice that all of these numbers here, so we have positive 2, negative 3, positive 5, and negative 4, all of those numbers are just half of your b value. So it is going to be useful for us to make note of this whenever you're trying to factor that perfect square trinomial. The number inside your factor is always going to be half of your b value if you did it correctly. So this is definitely an important little expression to know. We need to know that this c value is always going to be half of b squared. And we need to know that the number in the factor is always going to be half of b. All right, so now we're going to try the full process of solving a quadratic equation by completing the square. So the first thing we're going to want to do is get our equation in this form. We want one side of our equation just to say x squared plus bx, and then our other side should just be a constant. whatever number is left over. I do want to point out something super, super important. The a value does need to be 1 for this process to work. Then we're going to do this process of completing the square, which is essentially creating that perfect square trinomial by adding that b over 2 squared to both sides. So we're adding that c value on both sides to keep our equation balanced, and that will create that perfect square trinomial. Then we're going to factor that perfect square trinomial, noting that that number inside should always be b over 2. And then once we have that, just like that first example we did, if you have a binomial squared, you can take the plus or minus square root of both sides and then finish solving for x. So your goal is to turn this into a perfect square trinomial and then to factor that so you can take the square root of both sides. All right, so now we're going to give one of these a try all the way through. So our first step, remember, is getting our equation in that right form. So first, any constants, we want to move them to the other side of our equation, away from our x terms. So I'll subtract that 15 away. And then remember, when we're completing the square, this a value needs to be 1. So if it's something other than 1, we need to divide both sides by that number. So a is equal to 1. So now I need to figure out what that c value is, which sometimes I call it the magic number that completes the square. So remember, to find that, you take whatever your b value is, you divide it by 2, and then you square it. So in this case, our c value that completes our square is 4. So we're going to add 4. Don't forget to add it to both sides of your equation. All right, from here, we should have a perfect square trinomial, which we do, which we can factor into x plus 2 squared equals -1. And now gets to the point where I can start solving the quadratic. I can get rid of that squared by taking the plus or minus square root of both sides. And then here, I just need to finish solving for x by subtracting 2 from both sides. So we have -2 plus or minus. And remember, just by definition, the square root of -1 is I. So there are my two solutions, -2 plus I and -2 minus I. All right, let's try another one together. So again, we need to start by getting into that form before we start completing the square. So now I need to find that magic number. Now I do want to point out, whenever your b value is odd, it is a little bit trickier to use this method. If I was given the choice, I probably wouldn't choose this method, especially if my b value is odd. But let's go through it anyways. So I'm going to take my b value, divide it by 2, and square it. So our c value here is going to be 25 over 4. So that's what I'm going to add to both sides. So this gives us x squared plus 5x plus 25 over 4 equals 37 over 4. Remember, this is just 12 over 4 plus 25 over 4. Now from here, you're probably wondering, how in the world do I factor something like this? So here's where it's really important to remember that trick, that the number inside your factor is just going to be your b value divided by 2. So it's going to be half of your b value. So it's actually going to be x plus 5 over 2 squared equals 37 over 4. Now from here, I could take the plus or minus square root of both sides. Remember, I'm taking the square root of the numerator and the denominator. Then I'm going to finish solving for x by subtracting 5 halves, and then I am going to simplify whatever I can. Luckily, my denominator is a perfect square, and square root of 37 cannot be simplified, so I just have, I'm left with plus or minus the square root of 37 over 2. So you can write your answer like this. If you ever notice that you have that common denominator, if you would like to write it as a single expression, like all over 2, that's totally fine as well. They mean the same thing. So again, be careful when your b value is odd. You're going to be working with fractions, and it is really useful to remember that trick, that the number inside your factor is going to be half of b. All right, here's one for you to try on your own, so please pause the video. All right, go ahead and check your work here. So you can see that C value you should be adding to both sides should be 25. Be careful here, your factor should be x minus 5. So if your B value is negative, this number is going to be negative. Here you are taking the square root of negative 5, so that should simplify to I root 5. So we have 5 plus or minus I root 5. And make sure when you have something like this that you're always putting that constant out front. All right, so now we're going to talk about a different application of completing the square. So now we're not solving, but we can use that same process to help us rewrite an equation in vertex form. So here we know that we have this equation in that standard form, but let's say we want to graph it and we really like graphing from vertex form. We can rewrite it, and remember our goal is to make it look like this. This is that vertex form. So you'll see here, if we want to create a binomial squared, that's when we're going to need to complete the square. So we have to complete the square for our x terms. So the first thing I'm going to need to do is take this positive 18, which does not complete our square, and I'm just going to move it to the other side. I like to just clear it away altogether so my numbers are a little easier to work with. And now I need to find the number that actually completes this square. So remember, you take your B value, divide it by 2, and square it. So our C value is 36, which I'm going to add to both sides. So we got y plus 18 equals x squared minus 12x plus 36. And now we can factor this trinomial, which gives us this portion of our vertex form. So we have x minus 6 squared. And then to finish putting it into vertex form, I'm just going to move whatever this constant is back to the other side. So we have x minus 6 squared plus 18. So now we are in vertex form. So this is a different way you can approach graphing something that's in standard form. If it's easier for you, you can always rewrite it in vertex form and then go from there. I do want to caution that if your B value is odd, of course this is going to be a little bit trickier, so you might just want to stick to the original method. All right, here I have one for you to try on your own, so go ahead and pause the video again. All right, go ahead and check your work here. So again, let's get that positive 4 out of the way. Here, our magic number that we should add to both sides is 49 over 4. And then this will factor into x minus 7 over 2 squared. So remember, the number inside your factor should always be half of your B value when you have a perfect square trinomial. And then just subtract this to the other side to put it into vertex form. So again, this is just a different application of how you might use the process of completing the square. So it is a really useful tool for us, and you will use it for other applications throughout the year. All right, so now we're going to move on to a new way of solving, which is using the quadratic formula. Hopefully it's not new, hopefully it's a review for you. But first, we're actually going to derive the quadratic formula by solving this equation using our completing the square method. And that will give us the quadratic formula. So let's imagine I was starting this problem and I want to solve for x. We know the first thing we need to do is get that constant to the other side. So I'm going to subtract c from both sides. Now we know that this a value needs to be 1. So I'm going to divide both sides by a, everything on both sides, to make my a value 1. So we have x squared plus b over a x equals negative c over a. So from here, I'm ready to complete the square. So remember, I'm going to find that c value, I'm going to take my b value, which is b over a, and then I'm going to divide it by 2. So I'm going to say b over 2a, and then we're going to square it. So our magic number is actually b squared over 4a squared. Remember, you need to square everything in the numerator and denominator. So that's what I'm going to add to both sides. All right, here's what we have left, or here's where we are so far. Here, I am going to eventually work to combine these two fractions, but I'll do that in the next step. Okay, so now I need to factor my perfect square trinomial. So I know it's always going to be half of whatever my b value is. So it's b over 2a squared. And then on the right side of my equation, if I want to add these, I need to make a common denominator. So here I would need to multiply this fraction by 4a over 4a. So my denominator is 4a squared for both parts. And then I can combine it into a single expression. So we have b squared minus 4 times a times c all over 4a squared. So now that I have my binomial squared, we know that the next step of that would be taking the plus or minus square root of both sides. So we have the plus or minus square root of b squared minus 4ac all over 4a squared. Remember, I'm square rooting the numerator and the denominator. I am going to finish solving for x. So I'm going to subtract b over 2a from both sides. And then our numerator we can't really simplify, so square root of b squared minus 4ac, but our denominator is a perfect square. The square root of 4 is 2, the square root of a squared is a. So we have 2a. And then here you'll see that we can actually combine these two fractions because they have the same denominator. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. And this should look super familiar. This is our quadratic formula. But now that you know how to solve by completing the square, you can derive your own quadratic formula from this original standard form of our quadratic equation. All right, so now we're going to practice actually solving with this quadratic formula. So here it is again, this negative b plus or minus the square root of b squared minus 4ac all over 2a. I do want to point out that we're dividing this entire numerator by 2a. And this will give you the solutions to the quadratic equation ax squared plus bx plus c equals 0. So it is really important that you set your equation equal to 0 first. Also, please note that a, b, and c should all be real numbers and a cannot equal 0. Now, another part of the quadratic formula that we're going to kind of hone in on is what's called the discriminant. So the discriminant is b squared minus 4ac, which you'll notice is just the radicand, the stuff on the inside of your square root. Notice the square root is not part of the discriminant. So we can use the discriminant, so just the b squared minus 4ac, to actually tell us how many solutions we should expect and what type of solutions we should expect. So we know with quadratic equations, it's very possible that, so here's a parabola. It's very possible that it crosses the x-axis twice, which would give us 2 real solutions. It's also very possible that you have a graph that looks like this, so it's crossing your x-axis or it's touching it exactly one time. So you have only one solution, but it is also real. But we know it is also very possible to have a quadratic equation that never crosses our x-axis. It could also look something like this. So in this case, we would have 2 imaginary solutions. So this is where we're going to have those imaginary solutions, and imaginary solutions always, always, always come in pairs. Now we can tell which one to expect by looking at the discriminant. So if our discriminant is positive, think of what would happen if we finish solving here. You would have plus or minus the square root of some positive number, which just gives you 2 answers. Now, if your discriminant is equal to 0, here we actually have the plus or minus 0. So really that plus or minus goes away. There's no adding 0 and subtracting 0. That's the same thing. So that's why we only get one solution there, but it is still real. Now, if your discriminant is negative, we get the imaginary solutions because now we have the square root of a negative number. But remember, imaginary solutions will always come in pairs, and that's coming from that plus or minus right here. One last thing I want to point out, The quadratic formula is a super, super, super important formula to know. And it's really useful when solving because it will work for any type of equation, of quadratic equation. The other methods we talked about, sometimes they work well, sometimes they won't work at all. The quadratic formula will always work. So if you're ever unsure what method to use, your go-to should be the quadratic formula. You will always end up with an answer, so it will work for all quadratic equations. All right, let's give this first one a try together. So remember, when we're using the quadratic formula, it's super important that the first thing we do is set our equation equal to 0. From here, if it helps, you can actually define what your a, b, and c values are. You don't have to do this, but it's kind of nice. And I would also say, unless you really have it memorized, write out the quadratic formula as many times as you can so you really, really have it memorized. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And now all I'm doing from here is substituting values. So x equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 5 all over 2 times 1. Now, I really, really, really recommend that you take this step where you are just substituting a, b, and c. Whenever I see people try to skip ahead and do multiple things in one step is when I see small, silly mistakes. And they're completely avoidable if you are taking more steps. So please just take one step, substitute your values, and then start simplifying. So here we have negative 3 plus or minus the square root of, and even take another step here. 3 squared is 9. Here we have a negative times a negative, so it becomes plus 20. I'd say that this area right here is the most common place I see mistakes. A lot of people forget that they're multiplying. This is minus. So you just need to be really, really careful in this step. That's where I see 99% of the mistakes being made. Now it's just a matter of simplifying as much as we can. Here we have plus or minus square root of 29. Can't simplify square root of 29, so this is my answer. You can leave your answer just like this. You do not need to split it up into two separate terms, and you can absolutely leave a plus or minus in your answer. Last thing I want to point out for this problem, we do have two real solutions. I know it kind of looks like it's a single solution, but that plus or minus actually creating our two real solutions. All right, let's try another one together. So first we need to get one side of our equation equal to 0. So here we have minus 20x plus 4 equals 0. So I see that a is 25, b is negative 20, and our c value is 4. So we have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So if we keep simplifying, we end up with positive 20 plus or minus the square root of 400 minus 400 all over 50. So you can see that our discriminant is 0. So here it would be plus or minus 0. The square root of 0 is just 0. So that plus or minus is essentially going to disappear. So all I have left is 20 over 50. So that gives me my single answer of 2 over 5. So again, anytime our discriminant is equal to 0, we are going to have that one real solution. All right, here's the last one we're going to try together. So here we could keep this a value negative. It's my personal preference to usually try to make the a value positive, but the quadratic formula will work either way. But I'm actually just going to add the x squared to the other side and then subtract 4x. But again, you could do negative x squared plus 4x minus 13 equals 0. You'll get the same answer anyway. But again, it's just, for me, it's just a good habit to try to make your a value positive whenever you can. So here a is 1, b is negative 4, and c is 13. So we have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let's start simplifying. Here we have 4 plus or minus the square root of positive 16, and then minus 52, all over 2. This is why it's really important that when you substitute, you do it with parentheses, because here we are squaring the negative and the 4. If you don't have the parentheses written in, technically it would be negative 16. So it is important that you have those parentheses. And just get in the habit of any time you substitute, do it with parentheses. Now let's keep simplifying. Here we have the square root of negative 36 all over 2. So here you could see that our discriminant does end up being negative. So I know that I'm going to have 2 imaginary solutions. So I just need to finish simplifying this. So I know when there's negative inside, I put an I out front, and the square root of 36 is just 6. It's a perfect square, so we have plus or minus 6i all over 2. Now here we do need one more step to finish simplifying. If you notice that both terms in your numerator are divisible by your denominator, you need to simplify. It is a fraction. We always simplify our fractions. So we end up with 2 plus or minus 3i as our final answers. We have 2 imaginary solutions. All right, so here I have 2 for you to try on your own. So go ahead and pause the video and give them a shot. All right, go ahead and check your work here. So for this first one, again, you'll see that the discriminant is 0. So that's why we only have one solution. Make sure it's fully simplified. And for the second one here, since we have that negative discriminant, we do have 2 imaginary solutions. And then make sure that this radical is fully simplified. And then also please note here, all 3 of these numbers are divisible by 2, so you do need to simplify. And this 2 will turn into a 1. All right, so this last example we're going to look at really quick is just using the discriminant to determine the number and type of solutions to expect. So remember, we're just going to be doing the b squared minus 4ac. So for this first one, we would do negative 6 squared minus 4 times 1 times 10, and that gives us a discriminant of negative 4. So here, since our discriminant is negative, we would say that we have 2 imaginary solutions. All right, now if you look at this second example, again, let's just do our b squared minus 4 times a times c. For this one, we get 0, so that tells us that we will have 1 real solution. And then for this last one here, if we do our b squared minus 4 times a times c, for this one we get positive 4. So with a positive discriminant, we know that we will have 2 real solutions. Now, it is nice to remember that you can always check the discriminant. This is especially nice when you are working maybe with a word problem. Maybe it's good to check the discriminant first to see if you will even have real solutions, because there are going to be some word problems where you don't have a solution. It also might be nice to know if you have real solutions, how many to expect. So maybe before you do too much work, you do a quick check of the discriminant so you know what to expect. All right, so that is all for today's video. Thank you so much for watching.